A, and this formula is valid whenever denominator is non-zero. If denominator is 0, then we have to use the second formula, and it is x, and then 1 upon phi dash derivative of the denominator, and then again we have to use the first formula to solve the remaining part of example. Then if it is 1 upon phi of d a raised to x, replace d by log a. It is a raised to minus x, replace d by minus log a. Constant, replace d by 0. And the last formula 1 upon d minus a repeated r times. So we have to use the second formula r times, and that will give x raised to r, and divided by r factorial, and then e raised to x. Yes, we'll go through a few examples. Start on examples. Find. Acha, I have to start this. Create. Find CF, complementary function, right? 1 d square plus 6d plus 9y equal to pi u raised to x minus log of 2. Okay, so done. It should be find pi, particular integral is. Hope you remember the difference between pi and CF. अरे है ना, सबको याद है ना? I'm audible.
Yes, sir. Yes, sir. Yes.
So 1 upon d square plus 6d plus 9 operated on 5 raised to x minus 1 upon d square plus 6d plus 9 operated on log of 2. Yes, here we have to replace d by, yes, anyone? D is to replace by what?
A.
No. See, if it is like this, 1 upon phi of d e raised to x, then we have to write 1 upon phi of a e raised to x. Correct. Whatever you are saying is correct. D is to be replaced by a. Now suppose, sorry, 1 upon phi of d operated on a raised to x. Now what should be done? 1 upon phi of, yes.
D should be replaced by A.
नहीं ना रे यार, लिखे कि फॉर्मूला ली ना. I told you the formulas ना.
Log A, sir. Log A.
Log A. We derived the formulas also. We have to replace d by log A na. And what if 1 upon phi of d and constant is there? Then we have to replace d by, yes,
0.
d is to be replaced by 0.
0.
0.
Right now we studied these formulas now. So phi u raised to x, therefore we have to replace d by log a, and a is phi u here. A raised to x, compare this formula. A raised to x, so log phi u. And here we have to replace d by, yes, anyone? Log 2, what is log 2? Is it constant? What is constant? A term free from x is constant, na?
Yes.
Does it contain x? No, so it is a constant. And in case of constant, what we have to do? We have to replace d by 0. That's
0.
it. Okay, do it. So answer is 1 upon d replaced by log phi. So log phi u square plus 6 into log 5 plus 9 phi u raised to x as it is, minus 1 upon d replaced by 0, d replaced by 0. So what is remaining? Only 9 na? Log 2. This is the answer. Are you getting this? Are you
Yes.
getting this
Yes, sir.
answer? जेपते सर्वांना हे. Okay, चल next example. Right. Yes. D raised to 5 minus dy equal to 85 m alpha plus 2 raised to 3x. So write down. How we can write 2 raised to 3x? Okay, 8 raised to x. Yes, anyone? What should be done? Formulas are written here. Here are the formulas, you can use them. D is to be replaced by D is to be replaced by. Yes. In
No,
first
we-
case, D is to be replaced by. Does it contain X? अरे बोला
No,
काहीतरी? No, na.
No, sir.
So it is a
0.
constant. So we have to replace D by 0.
0.
Whereas in second case, we have to replace D by log of 8.
8.
But we are getting 0 in denominator. So what should be done? Maitri, batao आप. We are getting 0 in denominator, na?
Yes, sir.
So,
Derivative.
very good. First formula fails. Very simple. So what should be done? X and derivative. No change in this term. Again you replace D by 0. Now see what we are getting. Answer. Okay.
Yes, sir.
Any doubt here? Any doubt here? कुछ doubt है?
no, sir.
Okay, we'll go through the next example.
Sir, 1 minute.
Yes, complete it. Done.
Yes, sir. Done.
Okay. Now see towards screen and understand the next part. Okay. So shortcut method for trigonometric function. Okay. First, what we'll do now? We'll understand how we obtain the shortcut method for sorry exponential function, and then we'll find it for the trigonometric function. So it is like this. Hope you remember we started with phi of dy equal to f of x, but f of x was exponential function. And then we have written y of p equal to 1 upon phi of d operated on e raised to ax, right? This is known as particular integral. We know this, okay? Then, while finding the formula for exponential function, we consider this d of e raised to ax. And what is derivative of e raised to x? That is equal to a e raised to ax. Then we obtain d square. Okay, it was a square e raised to x, and now so on. We obtain third derivative. Then we obtain fourth derivative, and now so on, fifth, sixth, seventh, and so on. And then we decided that if possible, it is not possible in this way, but if possible, and if we are able to cancel, let me cancel e raised to ax from both the sides. So what is remaining? I am getting d equal to a. It is not so, huh? D square equal to a square. Then we are getting d cube equal to a cube. And then we are getting d raised to 4 equal to a raised to 4. So it will be sufficient to replace d by a. And therefore we have written the formula in this way, considering this. Again, we started with what the y of p is. So 1 upon phi of d operated on e raised to x. And since we decided replacing d by a, therefore the formula was 1 upon phi of a e raised to x. Hope everyone remember all these things. आठवते हे सर्वांना? Yes. हे
Yes,
काय तर
sir.
बोलत जा रे. तुम्हाला काय इंटरेस्ट नाही आहे का?
नाही सर.
यू आर नॉट इंटरेस्टेड?
दुसरं लेक्चर आहे ना तुमचे?
दुसरं बी आहे, तिसरं बी आहे.
तिसरं पण आहे?
हो.
तिसरं कोणाचं आहे?
एक मिनिट, हा. मेकॅनिकल इंजिनिअरिंगचं. हा जरा मेकॅनिकलचा वर्कलोड जास्त असतो. बरं, काय काम होतं?
हे लेक्चर मला आधी घेत होतं. सीडीसी आहे ना 12:30 जायचंय. मग नंतर टीपी 2 वाजेपर्यंत येते का पण? नाही.
मग दुसरं कोणाबरोबर ऍडजस्ट होते का बघ की. मग तुम्ही घ्या आणि मला दुसरं कोणाला देता येत असेल तर द्या. लेस प्रॉब्लेम वाटत असेल तर तुम्हाला घ्यायचं असेल तर घ्या, मला नेक्स्ट वीक मध्ये द्या. नको मला तर नेक्स्ट वीक मध्ये, कारण एक्झाम
11:30 वाजे घ्यायचं. मला काय प्रॉब्लेम नाही.
नाही, मला सगळं मेकॅनिकल लेक्चर असते.
हां.
11:40 ते की नाही 12:30 माझं मेकॅनिकल लेक्चर असते.
2 वाजेपर्यंत येईल का? एक नाही येत.
आज आहे सीडीसी तयारी आहे सीडीसी.
सीडीसी आहे.
होय का?
तिकडे आहे पण.
अच्छा, तिकडे म्हणजे आपले बी तिकडेच आहे का?
ओके. 12:15 जायचं तेव्हा पण घेतो.
चालेल चालेल.
12:25. 12:25 चालते. 12:15 निघायचं.
बरंच होते काय? येस. होप यू अंडरस्टूड दिस.
Yes, sir.
Yes, sir.
यार काय काय करताय का?
Yes,
मध्ये बोलत जा की रे काहीतरी. एक तर तुम्ही समोर नाही माझ्या, तुम्ही झोपून टाकले की काय करताय काय कळत नाही ना, लक्षात घ्या. आणि ते ठीक आहे, सोडून द्या. तुम्हाला समजले की नाही हे समजण्यासाठी ना माझ्याकडे दुसरा काय मार्गच नाहीये, आणि त्याशिवाय मजा येत नसते. शिकवणाऱ्याला तर ऍटलिस्ट मजा येत नसते. असं फक्त सांगत जायचं भाषण दिल्यासारखं, तसं नाही जमणार ना. चला आता now we'll see same procedure for the trigonometric function. So let me start. So d of sine of x. Yes, tell me what is derivative of sine of x? A cos of x, right? Na? Derivative of sine x is cos x, and then derivative of x is a cos x. Now tell me what is the second derivative of sine of x. So it is like this. See a as it is. This a as it is. Derivative of cos is minus sine x. Okay, and then derivative of x is a, na? So this a and this a. So it will be a square. Now tell me what is d cube of sine of x. Minus a square as it is. Derivative of sine is cos x and one more a.
Minus a cube.
A cube, right? So if we take d raised to 4, yes, what will be d raised to 4? Derivative of cos will be minus. Minus it will be plus, na? Right? Isn't it? Getting everyone? And now so on. Okay. Let me continue on the next page. So if I take fifth derivative of sine of x, yes, what will be fifth derivative? That will be a raised to 4 as it is. Then derivative of sine is cos of x, and then derivative of x is a, so it will be a raised to 5. If I take d raised to 6, so it will be derivative of cos is minus sine, and then derivative of x is a, so a raised to 6. And now so on. Getting everyone? Samajhte sarvana hai?
Yes.
Now see,
Yes, sir.
as in previous case, I want to write formula in this way. 1 upon phi of, we want to decide this, to be operated on sine of x equal to 1 upon phi of and sine of x. That is, I want sine x on both sides. Why? See the formula of e raised to x. We have e raised to x on both the sides, na? Isn't it? In the same way, I want sine x on both the sides. Right? Therefore, see what I am doing. I am cancelling this. Why? Since sine on one side, cos on both sides. So first derivative I am cancelling. I am cancelling third derivative. I am cancelling fifth derivative. जितने समझ में आ रहा है सबको? Right? Since on one side we have sine and on other side we have cos, therefore. Now see the remaining derivatives. I have sine on both sides, so let me cancel that. Then what I'll get? D square equal to minus a square, isn't it? Then let me cancel sine on both sides in case of fourth derivative. So I'm getting d raised to 4 equal to a raised to 4. Then in last case also I'll cancel sine on both sides and I'll get d raised to 6 equal to minus of a raised to 6. Right? So it is like this. D square equal to minus a square. D raised to 4 equal to a raised to 4. D raised to 6 equal to minus a raised to 6. And now so on. We can continue this. So basic term will be, we have to replace d square by minus of a square. And therefore the formula is d square. And here we have minus a square. Minus a square means square first and then minus sign. Huh? Be careful. Getting everyone?
Yes, sir.
Yes, sir.
Right. So in the same way, we can develop formula for cos also. Clear? Okay. So I'll write the 4 formulas. Right. If you want to write all these explanation, write it. If you want to leave it, no problem. But you write the formulas that I am writing now. Okay. It is compulsory to write the formulas. Let me write the formulas. You have to remember these formulas. Huh? It is expected to remember the formulas. Yes, right. Write with me now. The formulas are like this. 1 upon phi of d square operated on sine of ax plus b actually. Okay, you can try with ax plus b also. 1 upon phi of minus a square sine of ax plus b. What is to be written? Pi of minus a square is not equal to 0. This formula is valid until phi of minus a square is not equal to 0. Right. Second formula, 1 upon phi of d square cos of x plus b. So 1 upon phi of minus a square cos of x plus b, provided phi of minus a square is not equal to 0. Right. Now question remains, when phi of minus a square equal to 0, what should be done? So formula number 3. What should be done? Anyone? काय करायचं असेल सांगा. X 1 upon phi dash. Getting everyone? Have you understood these 4 formulas? Have you understood these 4 formulas?
Yes, sir.
Yes, sir.
Okay, so we'll go through examples now. Okay. Can I change the page?
1 minute, sir.
Write the 4 formulas. Acha, before we start the example, one homework is there. What will be shortcut method formulas for, right? Find, write homework, huh? I'll write on the next page. Can I change the page?
Yes, sir.
Yes, sir.
Homework. Find shortcut formulae for tan x, cot x, sec x, cosec x, and inverse trigonometric functions. You understand the inverse trigonometric function? Sine inverse, cos inverse, and so on. Find particular integral. Of following. First example. Sine of 4x. So d square is to be replaced by minus a square. What is a here? 4. So square first, huh? And then attach the negative side. Understood?
Yes, sir.
Yes, sir.
Okay. Okay, next. Sorry. What about d raised to 4? So now it is positive. Are you getting this answer?
Yes, sir.
Can I change the page?
Yes, sir.
Okay. Right. So this d square plus 9y equal to sine of 3x. First formula fails. So second formula x derivative. And what is 1 upon d? D is derivative. What is 1 upon d? Integration. Getting everyone.
Yes, sir.
Fourth.
Yes, sir.
You solve this 2 minutes. Anyone obtain the answer? Anyone who got the answer?
1 divided by -2.
Check करो पर. D square is -1. So what will be D cube? D into D square, but D square is -1, so minus D. Fails. Second formula. Now we have to replace D by so the answer is getting. Everyone is getting same answer.
Yes.
Can we go to the next example?
Yes, sir.
बोललो की काही शिक्षा होती काय? Okay. Very important example. We'll try to understand this type of examples also. See, it is like this. Okay. It is like this. 1 minute. Let me find one suitable example. Yes. Little bit. Okay. Little bit difficult, but okay. We'll try it. Right. Fifth example. D square. Yes, 10. Shut up. What about D as it is? Now question is how to remove this D. Since we don't have formula for D, we have formula for D square. D square is to be replaced by minus A square. So we do like this. Take -2 outside. What is remaining? D minus 2. Now to convert this D into D square. So we have to multiply numerator and denominator by D plus 2. Understood now what is to be done? Multiply numerator and denominator by D plus 2. So that we'll get D square in denominator. Okay. So D plus 2 minus 2 as it is. I think everyone know that this is A plus B, A minus B. Right. And what is their multiplication? A square minus B square. Very good. Now you replace D square by minus A square. That is minus 1. So it will be d plus 2 as it is divided by minus 2, then d square is minus 1, minus 4 and 2 we have written down 10 sine x. So d plus 2, what we have in denominator, minus 5 minus 10 into 10 sine x. Isn't it? Now operate the d plus 2 on sin x. So it is like
Plus in
this.
there, plus.
कस काय
That
plus?
is plus 10.
Minus 2.
हाँ. Yes. This is plus 10. Yes, this is plus. Yes, no doubt. So d of sin x into multiplication, just multiplication, 2 sin x. But what is d? D by dx. D by dx is derivative. Hope the example is clear to you. Go through the example once again and understand the procedure. Yes, understood.
Yes, sir.
Yes, sir.
ए मॅम म्हणू नकोस रे असं का करतोस ओके ग्रेट चलो नेक्स्ट
Okay.
हाँ कैन आई चेंज द पेज राइट I think you know these formulas very well. Cos A plus B plus cos A minus B do you remember these formulas? Everyone remember these formulas? Huh?
Yes, sir.
Everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
So you don't remember. Here minus sign is there. Okay? Attach minus sign for the last formula. Who remembers sin cube theta formula?
Three sin theta minus sin 3 theta upon 4.
काय सांगतेस Remember these 8 formulas. Done?
Yes, sir.
Very good. Done. Next. किती झाले रे example 6 7 what example we saw, how many examples we saw? I think 6
5.
5
Five,
झाले,
is
sir.
6 झाले.
Sir, 6 days.
okay, no any problem, whatever the number is not important, not so much important. D square plus 1y sine of 3x sine of 2x. So formula number 4, use the formula number 4. Isn't it? I considered minus sign on other side, huh? Hope derivation you understood. Isn't it? First formula fails. Can I change the page?
Sir, 1 minute.
Yes, sir.
Yes, please complete it.
Sir, done.
Okay. So second formula. Yes. Complete the remaining part of example. I have to change the repeat. One upon d is integration. Hey, getting ना? देखते हैं ना सर उन्हें? आ रहे हैं ना सबको समझ में?
Yes, sir.
One more and then we'll stop. No formula is there for sine square x, but we can write sine square x as how we can write sine square x? Operated on 1. I'm taking two different parts. Since two different methods are there, so I'm taking two different parts. Constant, na? One upon 5 is the answer of first part. Why P1? Cos 2x. Can I change the page?
Yes, sir.
Everyone has written this.
Yes, sir.
Ha. Hey, what was there in denominator? I have the 16d square. So 16 into minus 4 minus 1 and then cos of 2x. D is derivative. Let me take minus sign outside. Clear? Understood?
Yes, sir.
Yes, sir.
Little bit lengthy. Okay. Thank you. You can leave. I'll take attendance in next lecture. We have a lecture at 11:40. Please join at 11:40. Thank you. Bye bye. काय डाऊट आहे? चला मला फर्स्ट इयरचं लेक्चर आहे. बंद करू का?
थँक्यू सर. थँक्यू.